Hello everyone, welcome to another Mitsubishi Electric Podcast. We took a while because we had a longer summer break, but we are back talking about automation, robotics and so on in many different industries. And today we'll be talking about data centers, which honestly speaking, it's the topic that I know the least about. So that's why today I will count on my guest to provide me a little bit of knowledge about the data center market. I'd like to mention a couple of things first. So as always, we will have 40 minutes conversation and then a couple of minutes for Q&A session. However, there is a new thing that we are testing. So here on the screen of the podcast window, you will see a possibility to actually register for a call with my guest. So for example, if you have some additional questions or some things are still unclear, or you simply want to chat about the topic, you can directly book your slot here. So I made sure that Rick has couple of slots in his calendar open for you. So feel free to register for this kind of conversation. You will have a possibility to integrate this with your calendar if you want to have this kind of meeting with us. And then I'll start now. So again, topic of data centers, and I have Rick with me, who is going to lead me through the amazing world of data centers. But firstly, I think, Rick, it would be great if you could introduce yourself, because, well, who can do it better than you?
Well, thank you. And thanks for the invite to have time to be here. So I'm Rick van der Kooij. I live in the Netherlands with my 2 kids and 2 cats. And I'm the Director Data Center Application Engineering for EMEA. At Mitsubishi Electric. It's a mouthful, but generally I'm responsible for the engineering and delivery of our projects in the data center industry. Before I joined Mitsubishi Electric, I've worked at Interaction, which is a digital realty company, and I worked there in the inside of the data center at the heart of the operations department. For roughly 14 years. And what I really liked about it is in that industry there's so much going on. When I started there, I was just a site engineer and walking around every day in the data center and had to manage every bit of the data center, so the electrical part, the mechanical part, but also customer questions and supporting their needs for hands-on ICE requests and support. And in my time there, I've built up my knowledge around monitoring and DSIM. Because when I was walking around the data center, I had to react on alarms, and just giving me the notion that, well, there's a unit in alarm, you have to go check it out. I wanted to know more, and there was my experience of building that DSIM platform was very helpful, because I connected all the bits and pieces in the data center towards that monitoring system. And by doing that, I learned a lot about all the facilities from the data center. So from UPSs to generators to MV, LV switchgear, everything got connected, and I had to understand, all right, how is it working? What does it do? So I can interpret that into a monitoring system so that it could tell me later on, right, this is what's going on, instead of, well, go check it out. And by building that up and working inside that operations department, I could, learn about all the facets of working in such a company, like project management and commissioning of data centers and the new build and the design and engineering and how to work with our end customers. And by having that knowledge, when I joined Mitsubishi Electric 1.5 years ago, I brought that knowledge into a company that really wanted to expand and to grow inside the data center industry. So that helped my team, it helped myself a lot to really come from a customer perspective into this organization, where I could build up a vertical team that brings solutions to data center industry.
So you have all this inside knowledge about how data centers operate, and first of all, you can utilize it in your work, but for sure you can share your experience with us as well, even using this kind of opportunity like this podcast, right?
Yeah, definitely.
All right. So I guess this is the first time that the robot is not that important topic in the conversation. However, I'm looking forward to what you have to say. But I'll start with something different, I'd say, because these days you hear a lot of information about new data centers being built. So I can imagine a place where my data lives, which is a huge facility in the middle of nowhere, consuming all of the energy just to, so I can look at the pictures of my dog or something. And I think that there is sometimes a little bit of controversy about the data centers because they don't seem to have like a very good public image. So what's your take on that? How do you perceive this situation?
Well, yeah, it is correct because the data center industry is using a lot of power. It's immense, and data centers are almost everywhere, but they are centralized in certain places because of network connectivity. And if you look at how that's been placed in the market or in the news, when a new data center comes up, it always, 90% of the time, it always refers to the amount of megawatts is used. So Microsoft is building a data center for 150 megawatts, and Google is expanding with 50 megawatts, and Amazon. It's always about how much power is a data center consuming, and that's the image that the public is getting. And actually, that's a little bit hurting us as an industry because more rules and more legislation is coming to sort of contain the growth of data centers. And in my opinion, we should sort of change that image to the public and talk less about the power consumed, but talk more about why that data center is there and why is it needed. Because everyone is using data centers, like you mentioned your picture of your dog, but also your Netflix, WhatsApp, in your work environment, your Outlook, your Teams environment. Everything is in data centers somewhere. And if we portray that into the news, that a new data center is built for the use of, expanding your Netflix usage, or making sure that hospitals can communicate better, or making sure that homeschooling your kids during a pandemic is covered. And I think that will change the public opinion about data centers a lot. And in the end, that will help us as an industry as well, because with all rule sets that are coming, you have the local authorities that need to do something with it. They will, of course, listen to their public because they need their votes, and will maybe decide to vote against coming for a new data center. But if the public changes, the public image changes, then they will be more helpful to get data centers up and running, which is good for every industry.
But I'd say, obviously, megawatts is not the only thing that matters when it comes to data centers, and all these points that you're making are clearly correct ones. But I guess somewhere there is a consideration about the efficiency of how this energy is used. And again, maybe the public image is not that great, but I have an impression that generally speaking, data centers are efficient when it comes to energy consumption.
Yeah, true. In my opinion, the data center industry is one of the front runners of becoming more and more efficient, because it's a hot topic. Everyone is talking about efficiency and sustainability in the industry, but the growing demand of computing power is immense, and therefore the need to become more efficient as well. If you look at the FLAP-D region, the area there is almost full and out of power, and they're struggling a lot to fulfill the demand of.
Sorry, FLAP-D being?
Yeah, that's a good one. The FLAP-D areas in the data center industry are the sort of the cities that are having the most computing power, so the most data centers available there. And that's Frankfurt, London, Amsterdam, Paris, and Dublin. And those are the regions that, well, attract more data centers, because there's already a lot of data centers there, and it helps to be very close to each other, because connectivity is always a big part of locating your data center. So on one hand, you have your power demand, and you need power to run your data centers, and on the other hand, you have your network availability. Some data don't need a lot of network speed, and then you can place them wherever you want them. But a lot of data needs to be transferred very quickly, and then you don't want any latency. For instance, if you're sitting at home and your Netflix movie, constantly has to load because it's miles away, you want to have that closer so you have a smooth Netflix movie.
Right.
But that's only very physical. You have a lot of industries that are demanding high frequency power, high frequency networking as well.
All right. So Rick, what I usually tend to talk about during those podcasts is also I want to understand different forces, different trends that are shaping a given industry. And when it comes to data centers, I think you mentioned one of them already, which is the energy efficiency, and how a related problem to it, how you can actually modify the public image of the data center so people understand the efficiency that is behind them. But what are other trends that are shaping this particular industry?
Well, if you look at the data that's behind this, of course, the AI platforms, the cloud platforms like Amazon, Google Cloud, they are rapidly expanding, and the demand for more and more and more is driven by those kind of needs. And one of the parts then as well is it needs to be faster. So that means where 10 years ago data centers got built in like 3 years from start of the design till the actually running of the service inside the data center, now we were looking at 12 months lead time. So that means it's sort of a pressure cooker where everything needs to be more efficient, not only the power efficiency, but also how to deliver that data center and how to have shorter lead times on the products and the techniques that are used inside a data center. And one of the parts, in my opinion, where that comes into play is containerized solutions, is to bring down that lead time.
So these days, 12 months is, would you say, an average time to commission a new data center?
Yeah. Most of the time it's within, really from the start of the engineering to physically build it and deliver it so that the IT power is up and running. is 12 months.
Well, that's a, let's say, a short time, but I guess we'll talk about this later a little bit as well.
Yeah.
Well, yeah, I think that also the pandemic changed a lot. I mean, from what I was, reading in the press from that time, like the need for computing power and for the storage was growing really, really fast. Even like people were changing from the office type of work to online meetings. So this hugely changed the way how we use data. And it seems we are not going back to the old times, right?
No, and it's only getting more and more. I mean, companies are even closing offices, physical offices, so more working from home policies are incorporated. And you saw during the pandemic as well that a lot of homeschooling was done. Well,
right.
Couldn't have done it without data centers.
All right. So let's say we have a very dynamic industry that requires you to build a new facility every 12 months. We have all the needs that people have towards data and dog pictures and so on. So maybe we can go inside a data center and, let's say, using your experience, maybe you could explain how typical data center is organized and what are the typical challenges that this type of facilities face.
Yeah, well, one of the biggest challenges, I think there's a shortage of everything in the data center industry because there's always the challenge to find good people to work inside the market. There's not a real education to become a site engineer or whatever, and there's quite a large market around the data center. So from having people inside the data center to also all the maintenance crews and service delivery people around the data centers, manpower is definitely a big challenge. So what you see in data centers, yes, the facility needs to be very efficient, but also the organization needs to be very lean and efficient. So a small team that runs a data center is backed up by central teams that centrally manage the maintenance and project management for rollout of new customers or even new data centers. But also engineering and procurement teams are all quite small and narrow teams. And it's a struggle to find the good people, but on the other hand, this is how the data centers are shaped. So that's not really something that's going to change. Even if we find the people, then still the data center will be run by very small and narrow teams.
Wait a second. You said you don't see people being educated to be a site engineers. What is the typical educational background in this industry? I mean, what kind of people you actually target? What kind of people you try to, let's say, develop to be like perfect site engineers for data centers?
Well, the perfect site engineer is sort of how do you say that, 1,000-leg creature that can do everything at the same time, so you can be really efficient with your team. So someone that understands the electrical parts and the mechanical parts and the IT part in one. That's perfect. But you see that more and more teams are slightly dividing that in, well, we have the facility team and an IT team that manage the customer requests, and the other one is managing the facility side of things. So electrical engineering backgrounds or mechanical engineering backgrounds are commonly seen. And actually what we've seen is a lot of people that are working in the Navy are coming over to the data center industry as well, for the simple reason that a ship is almost similar to a data center. It has its own generator set, its own power creation, it has network, it has cooling, it has all the aspects. And a data center on itself needs to run independently as well. If the grid fails, then of course your generators and your UPSs will take over the complete load to make sure that the operation of the data center always continues. And that's the same with manpower. I mentioned the call-out shifts and being on call to react on alarms during nights and weekends. That's the same in a data center as in a ship. You're sometimes
very interesting. So you mentioned a little bit about again how data centers are organized. But you mentioned something about having this distributed type of approach when I assume headquarters are in charge of designing, developing the solutions, and then somehow they have to be managed in many different locations. Is that the case?
Yeah, what you see is because they have small and narrow teams centrally organized, you want to work, at least that was how I would always looked at it, is you want to really work with partners. So they need to sort of organized in a similar way, where you don't have to talk to, as for instance, a procurement team or an engineering team, you don't want to talk to 20 different people for 20 different products to get your data center up and running, and to do your procurement and your engineering. So I demanded from my own supply chain that, well, I wanted a narrow way in their organization, and I want real partnership. So someone that really runs fast for me. Mm-hmm. If you have a question, you want an answer, because everything is on a time pressure. So you cannot wait for 3 weeks to have an answer. You need, immediate actions to get to where you need to be. If there's an issue to solve, then you need to solve that issue quickly, because the danger is that you have downside in your data center. In the whole procurement and delivery part of a data center, if you have to do everything within 12 months, then you cannot wait 2 months for an answer. You need to actually have that answer right away.
Well, it goes a little bit against my intuition, because I always imagine data centers being like huge companies with, let's say, lots of resources. But what you're describing here, small team that has to act quickly, so has to be very lean, like in very productive factory, let's say. And then again, you want to have this kind of local presence, you want your you want to know the partner, right? You want to know who are you working with, right?
Yeah, and that's if I may say so, that's the insight and the knowledge that I want to bring into Mitsubishi Electric as well. Is right, how are we going to shape ourselves towards the market? Because, well, I've been in that seat. I was the customer. So what did I want at that time, and how can we shape our team in the same direction? So centrally organized on an EMEA level, narrow street of communication, but with a huge backing of a company that's present in pretty much every country, and really be the one to say, well, we're going to run as fast as we can for you, and really sit next to our customers to build that relationship, to learn from them, to see, right, how do we need to act and where can we work together. And even in a pre-designing stage, already think with our customer, right, this is what we can do, how can we change it, how can we optimize it, how can we, well, think about all the containerized solutions that we can develop and we create in our factories, and to really work together as a partner to have the same end goal, is to deliver that data center in the most efficient way with the highest quality. Because of course, quality is still a very important thing. And I think that's one of the choices I made why I really wanted to join this company is right, with our products, we have a very strong reputation of quality. Perfect. Now let's focus on our next core value for us, and that's partnership. Really work hard for our customers to deliver the best we can.
All right. And of course, all that makes sense, but again, it goes a little bit against my intuition. But that's why we have this conversation. So you mentioned a couple of times already the topic of containerized solutions. And I guess that's something that is very important to you in this particular industry. And maybe we could start with one of them, because from what you described, how the data centers work and how they are organized, it seems like this type of remote monitoring and remote connectivity is very important. And this is actually very similar to factory automation, industrial automation type of applications, because we seem to have more and more distribution when it comes to like places where the things are actually happening, and let's say centralized headquarters that need to manage all these different facilities for the best, let's say, performance. So it seems it's very similar, but maybe you can elaborate how you manage this kind of, let's say, need for remote connectivity.
Yeah, well, if you look at that part, of course, our Iconics DSIM has a very good way of visualizing working as an umbrella system. Even on multiple data centers cross countries, we have a complete umbrella on top of it. That gives a very good insight in how is it running, how efficient is it, where can we optimize, even with artificial intelligence platforms behind it that supports the way, right, not just looking at pieces of the data center, but looking at it as a whole. What happens if we change something here? What happens then down there, or vice versa? But also collecting all that data into an umbrella system so that you expand your knowledge not from one data center, but from all the data centers. And then connectivity comes into play again, of course, where centralized teams.
Environmental performance, running cost, achievements.
To optimize that data center.
Okay, but maybe let me go one step back. What is containerized solution? Maybe let's start with that. What do you call a container? Let's say
a containerized solution is very broad, actually, because you can have a small container for just the batteries of your UPS, or for just the LV boards, or you can have a complete data center in a container. So from a few racks into a container to even hundreds of racks, the containers are completely shapeable and changing in formation and size, whatever is needed at that moment. And in my opinion, with containerized solutions, you bring down your lead times, and it's more safer. I'll get to that in a moment. It's more efficient, and in the end, because it's more efficient, it costs less money to build that up, and it's easier. You drop in sort of modular building blocks into a data center and build that up, connect it to each other, and you have a full data center. I still believe that civil works around it, or parts of data center that require normal rooms with normal structures will still exist. But I think in the future we'll see a lot more containerized solutions, for the simple reason that You have to picture it that if you need to build up your UPS or your LV switchboards inside a data center, then you have to send someone there. You have to send your equipment there, but also you have to bring your tools and really build that up into a construction site. So you have travel time and cost from the engineers that need to do that towards the construction site, wherever that may be, because it can literally be everywhere. It takes time because they need to go through the security checks, because you cannot just enter a data center. There's always high security levels. You have to work in a construction area, so it needs different PPEs and different ways of working. And if you forget something, you don't have everything by hand. And that goes from small containerized solutions to big installations. It doesn't really matter. But if you then take all that work into a factory, it immediately creates a lot of efficiency, because the people that work there are already working there every day. They know their way around. They are familiarized with their surroundings, so they're not in a brand new site, and also not in a risky construction site, a construction area where there's always a risk of I don't know, something falling, or floors are not done, or walls are still open.
Well,
where
they have only 12 months to build it, so.
Yeah, exactly. So if you do that in a factory, it's very efficient, because the tools are all there, and the tools are completely optimized to the space that they are there in, and it's a lot more safer environment as well. So health and safety for the workers that are doing the actual work there is a lot better. And if they forget something, my screwdriver, or maybe even just a screw or whatever, they have everything in that factory. And if someone gets sick, you have more people in that factory that do the same work. And everything is closer tied to each other. Mm-hmm. So it affects your efficiency and your lead times. And with efficiency, it becomes cheaper to construct it. Health and safety is, of course, a very big plus. But also the quality. Because you have to think, if I have to construct something here, where the walls are still being built around, then there's dust and everything coming into your solutions. Where if you do it in your safe, clean environment of your factory, then your quality of your end product will be a lot better as well. Mm-hmm. And then it's easy, ship it to location wherever you want it. And even being lean and efficient is optimizing a sort of standardized design towards local legislation on fire prevention, fireproofing, but also on noise levels and emission levels. It's all, you can easily adjust your sort of your building blocks.
Yeah, but so it all sounds perfect. I mean, clearly there are different industries that go in this direction of having like building blocks that are, let's say, tested, ready to use, and you just kind of create the application from them. One doubt that I could have about this is, are those facilities similar enough to use this kind of building blocks all the time? I mean, I assume there is always ability to adjust, right? But can you really standardize the operation of data center in a form of this kind of ready-to-use building block?
I think you can standardize a lot more than what we're currently doing. And in the end, you want to sort of work towards a design that fits your own organization as a data center operator, so that it's easily maintainable and easy workable for your workforce in the end, because in the end, the site engineers need to work with that equipment that's in there, so it needs to be, easily maintainable. But yeah, I think it makes sense to sort of design standardized blocks that you can say, well, I now need something in Germany, or I need something in Portugal, or in Spain, or wherever you need it, and you make minor adjustments to the different rules and regulations that you have. Because, don't get me wrong, Germany has completely different rule sets about what data centers need to comply to versus Portugal. And it's not like you have 3 different flavors. No, pretty much every country, and sometimes even every region in a country, can have different set of rules, but you can still adjust quite easily because you build them in a factory where your factory around it is very stable and secure, so you can make easily adjustments to your containerized solutions.
Sure. When I think about similar approaches in, let's say, typical factories, one other reason to use this kind of approach is, let's say, lack of, let's say, engineers. And I'm not talking about, let's say, that, I don't know, we are not able to afford for more and more engineers. That's not the case. The problem is that it's hard to find them. So when you standardize and then you deliver those, as you said, building blocks that are, let's say, very standard, very well documented and so on, then maybe the need for engineering at the, let's say, end user side is reduced, right?
Yeah. On one side, you can definitely, when standardizing, it saves engineering on the central team, because, well, create one engineering design and then only adjust towards regulations, but also adjust to, new optimizations, instead of that you have to redesign everything from scratch every time. And in the operations, it helps when stuff works the same everywhere, and you need to make it work smart. So there's sort of sets that you can do, but also looking at monitoring systems and artificial intelligence programs around it that can help engineers do their daily job. With the example that 14, 15 years ago, when I just started, I had to run around the data center collecting values to do my monthly reporting. And also, if there's an alarm, I always had to go literally to the place, then find out, right, this crack unit is an alarm, why is it an alarm? Then I had to go to the chiller and to the pump platform to take all that information, where the monitoring system is now taking over that part. And I think next step is that artificial intelligence will take over a huge part of that supporting layer towards the engineering and towards the operational teams to help decision making during incidents, decision making during maintenance, by decision making based on big data, to bring your data center facilities to the next level of efficiency.
Right. And that was actually my next point. I was eager to ask about AI for sure, because this has become a hot topic everywhere in pretty much any industry, and it's amazing how it shapes everything, really. But maybe a different question then. So, okay, could you outline your vision for the future? How the future data center could look like, in your opinion?
I think I pointed a few things right out. I do believe that even though we are already on the right direction to become more efficient, I think in the coming years we will be, as an industry, become hugely more efficient. And I believe we can build data center in a smarter and faster way than we're doing right now. Easily managed, easily maintained, so that workforce can be either easily found and easier trained. And next to that, with artificial intelligence programs, make it more efficient. And as well, look at, well, what can we do more with data centers? And this is a topic we haven't touched yet.
All right.
But data centers creating a lot of heat. And I think if we're looking at the future, one of the main things we need to talk about and we need to make sure that it's getting there is reusing that heat waste from data centers into other industries or residential areas to become more better for the environment as well.
Okay. And are those things tested already? I mean, using the heat to...
Yeah, there's already quite a few data centers out there that are actually doing it. There's a few challenges around that. One, the technical side, it's there. Heat pumps and everything, the techniques are existing. The challenge is how to get the heat to someone that can use the heat. So of course there's investment needed for, pipeworks or something that exchanges the transportation of the heat. But then you come back to local politicians again. I think they are very essential in this role because they should have an overview of, all right, a data center wants to build here. What are we going to sit next to it?
Right.
Is there a residential building next to it or planned to be if it's a new build? Hey, let's think about how to connect those two. You have a brilliant image again because then you can say, all right, new data center has been built, all the heat that's not thrown away but is reused in the residential, which then feeds back into the public. But also think about, all right, I have, as a local politician, I got a request here to build a new data center and I got a request for, a tomato plant. Whatever.
Right. Mm-hmm.
Why not try to put those next to each other? Instead of putting them miles away next to each other so that they can, benefit from each other.
So in essence, the future that you are outlining is a data center that is very lean in operations, that is able to do the whole commissioning very, very fast. Data center that is able to analyze its assets with the artificial intelligence to take better decisions, for example, about the energy usage.
Yep.
And also a data center that actually can benefit the society with a completely new features, let's say like heating, right?
Yeah, exactly.
It's very interesting.
I was actually thinking, this morning you mentioned about a robot, and actually even thinking about containerized solutions and then thinking about robots and supporting the workforce that is needed to do stuff. I can imagine that in the coming years we will see solutions on the market where you have a containerized solution with IT racks in there and a robot that does maybe the racking and stacking of servers and et cetera, et cetera. So, well, you have to think of if you have a blade server for, 10 heights, it's quite heavy to lift that inside a rack. Well, maybe that's going to be the future for robots.
That was actually, I wanted to ask this question. So because this time our robot that is always here on my podcast, it seemed like it was irrelevant for the topic, but you're saying that in future it is possible actually that they might be used, to streamline the operations, for example.
And I think that's the fun thing of our company as well, is because we're so diverse in our products and our solutions, it's, well, how can we use all those assets to optimize data centers? And I'm only thinking about data centers. It's the only thing I have to worry about and want to worry about. But then looking at, right, this is what we have. Hey, hang on. Yes, a robot could definitely be an asset and they could definitely improve the life of a site engineer as well and make it more efficient. So there's definitely space for robots.
I'm relieved, let's say. Rick, it is wonderful to talk to you, but we are way over our time.
Very good. Sorry.
I really wanted to spend a little of time for Q&A session. And there is actually a lot of things going on in the chat. So many messages, but I will share this with you, of course, but I'm searching for questions. And the first one was about Actually, the training and becoming a profile of a person that could actually join data center operations. And we have a question from a project manager who is a civil engineer with civil engineer background and would like to obtain training to work in this industry. Do you have any recommendations how to start with this?
Well, there are several companies out there that are actually giving data center trainings, but in my opinion, they're quite expensive. So if you're working for a company that really wants to invest in you, then it's definitely worthwhile looking at those. Actually, I don't know from the top of my head, but we'll write down that question and I'll post a few that I know later on my LinkedIn.
Sure.
But I believe that we still need to work more towards educating in the normal school life that we already have to become more aware and knowledgeable about data centers. Because to be fair, my personal training and how I grew up within the data center industry was learning by doing and being taken by my colleagues, right? This is how we do it, this is where we do it, and then develop that knowledge along the way. But yeah, like I said, I'll definitely post to several companies out there, and I know that a lot of data center association groups are also pushing towards more education and everything, and it's one of my topics as well that I want to invest my time more in the coming years to, I don't know, go to schools and train more people to be knowledgeable about data centers.
Mm-hmm. Well, this person also mentions that he's a project manager, so I think that like this kind of project management background is really helpful.
Yeah.
So of course it's a different industry, but somehow you can pivot if you have this kind of skill set for project management, right?
Yeah. Myself, I did Prince 2 several years ago, so that's just a general project management style,
right,
that you can learn, and that's perfectly suitable.
And it's used in data centers.
Yes, definitely. Okay. So of course you have a lot of different ways to organize work, like Lean and ETIL and Prince 2 and stuff like that. They're all very suitable to work inside data centers, and it definitely helps to have that experience to bring that into the data centers. And on one hand, data center industry is very innovative with a huge amount of smart people working inside, developing the industry, but you still see that other industries have a certain knowledge and mindset that are very effective inside the data centers. Like if you're working in the naval industry, in the shipyards or ship industry, or in oil and gas, there's quite a lot of similarities. So if you're at this moment working in different industries, definitely look at if you can change your way of working if you want to go to the data center industry, because I think that bringing that knowledge from outside industries into the data center market is very valuable as well.
Mm-hmm. Right.
Vice versa as well, coming from the industry, going to different companies like I did that wanted to focus on data centers is very interesting as well. And then you can see, right, how is a different company operating and how can we leverage that with the knowledge that we already have inside the data centers.
Sure.
Like robots.
Changing the topic a little bit, however, there is a comment about this topic of reusing the heat, and our guest mentions that, well, definitely the heat reuse will transform the industry, and that the Nordic countries are way ahead when it comes to utilization of this.
Definitely, yeah, definitely. Nordics are, I mean, even with their green energy, you see a growing demand in the Nordics for data centers. I think I don't want to offend anyone, but I think they're a little bit behind on network connectivity. So that's why it's not so rapidly as the FLAP-D regions. But yeah, you see a growing demand there because of the green energy, the sustainable solutions that they have. They're way ahead. And I think the knowledge that is gathering there, we need to spread that out. About the rest of the industry. And of course, every region has its different challenges. I mean, the things that the Nordics can do is a bit hard to do in Africa or Turkey or that because of the climate differences. But still, yeah, Nordics are doing a very good job on reusing the heat waste and being efficient and having that sustainable energy supply.
Honestly, it's a wonderful idea. I mean, why to waste all this heat if you can actually use it?
Yeah, well, one of the challenges there is as well for local politicians,
right?
Because I heard not an expert on that part, but I do hear stories that some data centers are not allowed to share their heat. They are completely ready. They have the solution. Only they just need a user on the other side, so to say. But then they're classified as an energy company. And of course, data center is not an energy company, and then they're not allowed to give away that heat. So there's still, lots to do, not only on the technical side, because the technical side is already possible, but on rules and regulations, there's still a lot to gain.
Well, regulations are always a topic in Europe, right? I mean, in every single industry. Okay, a little bit about, let's say, our future, your and mine, let's say. So there is a question from a person working as a disaster recovery manager. Are we planning any podcast to discuss this aspect? And this is, I'm open, but that's up to you.
Yeah, well, yeah, sure, let's do it. I mean, maybe we can even invite him to discuss those topics, because disaster recovery is, on one hand, there's a lot of parts in the data center that, of course, we need a high uptime. 99.99% of the time the data should be available, the power needs to be available. So there's that disaster recovery. But also, if you look at the pandemic, that was sort of a disaster recovery. Or how can we operate schools, homeschooling, companies, whatever, and then data centers are part of that. And actually, during the pandemic, I don't know if it's in every country the same, but in the Netherlands, where I live, data centers were classified as an important industry, same as hospitals and everything. So a data center engineer were still allowed during lockdown periods to travel to the data center to make sure that it was stays up and running. So it's the data centers are very important.
Well, they became really important during that time as well, right? All right. We have some questions about your LinkedIn profile, but that was sorted out. Okay. Your name is pretty characteristic, so it's easy to find you. Someone else confirmed this point about the legislation towards the heat distribution. So it seems to be topic that is. This is another controversial issue, but we don't have time to discuss this today. Perfect. So I'll finish here. Please remember that you still have chance to schedule a call. We started doing this just to know our audience a little bit better. So, for example, if you have like a specific topic like the disaster recovery, issue, feel free to schedule a call with Rick directly. As I said, he still has a couple of slots in his calendar open. Rick, it has been a pleasure. Hopefully see you next time. Thank you for being here with me.
Definitely, thank you too, and it was definitely a pleasure. And looking forward as well to all the meeting slots and discussions that are upcoming with it.
So thank you everyone, and talk to you soon.